Hello, I am Muhammad Rashidin. I will explain about introduction and definition of standing wave in musical instrument. Six. Definition of standing wave in musical instrument. So we look at in standing wave. What is standing wave? Standing waves, they are waves that do not travel but oscillate in place. They are created when two waves of the same frequency and amplitude travel in opposite direction and interferes with each other. In musical instruments, standing waves are essential for sound production, such as in the guitar, violin, and some else. Then we have the notes, which point of no vibration, which the waves do not move. Then we have antinodes, which point of maximum vibration. The wave move the most. So we look at it. What are the standing wave in music? Standing wave form when a vibration medium like a string, air column, or membrane create interference between waves traveling in opposite directions. This wave lead to the production of musical sound through resonance within the instrument body. Why is so important the standing wave in musical instrument? They govern the frequency, pitch, and timbre of the sound produced by the instruments. They are formed by vibrating the string, such as guitar, violin, a corner like a flute, trumpet, or membranes like the drums. So next, I will explain about the theory of the standing wave in musical instrument. First, formation of standing wave. Standing wave occur when the two waves traveling in opposite direction interfere constantly and destructively. The wave pattern appears stationary with nodes with no movement and antinode maximum movement. So, what the element in standing wave? The key element in standing wave first is a frequency, the number of complete cycle of the wave per second. The frequency determines the pitch of our sounds. Wave, next we have the wavelength, the distance between two consecutive notes or antinodes. Next we have harmonic, higher frequency that are multiply of the fundamental frequency. This contributes to the timbre of the sound. We are looking at example of standing wave. First, in string instrument, the strings vibrate between the two pitch points with notes at the ends, such as like guitar or violin. Next, we have wind instrument. The air column inside the instrument vibrate with notes and antinodes, determined by the instrument length and the position of the open and the closed end, such like flute, clarinet, and so else. Next, we have percussion instrument like drums, bass. The drum vibrate, creating a standing wave pattern with notes along the edges and antenna in the center.
Next, I will be explaining about the characteristic of the standing wave. So, for the characteristic, there can be a transverse and longitudinal. In the standing wave, their total energy associated with a stationary wave is twice the energy of each of incident and reflected wave. All the particles in one particular segment vibrate in the same pace. The particle except those at nodes execute simple harmonic motion about their mean position with the same time period. The amplitude of vibration of particle varies from zero at nodes to maximum at antinodes 2A. All points except nodes pass their mean position twice in one time period. The velocity of particles while crossing mean position varies from the maximum at antinodes to zero at nodes. In standing wave, if amplitude of component wave is not equal, resultant amplitude at nodes will be minimum but not zero. Therefore, Some energy will pass across notes and waves will be partially standing. Next, I will be explaining about how the standing wave works. Here we got some image. Okay, from this image, it illustrates the formation of a standing wave in a medium, such as a string fixed at both ends. How a standing wave works? First, superposition of waves. A standing wave is formed when two waves of the same frequency and amplitude travel in opposite direction and interfere. In this case, the incident wave traveling to the right and the reflected wave traveling to the left and combined. Second, nodes and antinodes. For the nodes, these are points of zero displacement where destructive interference occurs. The waves cancel out each other. And for the antinodes, these are points of maximum displacement where constructive interference occurs, which is the wave reinforce each others. Third, fixed end. The string is fixed at both ends, so the displacement at those points is always zero, forming nodes. Fourth, the distance between two adjacent nodes or two adjacent antinodes is half the wavelength. The distance between a node and adjacent antinode is 1/4 of the wavelength. 5. In a standing wave, energy is not transported along the medium. Instead, it oscillates between kinetic and potential energy at specific points.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ab.Rahman bin Ab.Rahman and I will continue with the application of standing wave in musical instrument. Musical instruments like guitar, flute and drum use standing wave to make sound. These waves are pattern of vibration that stay in one place with some part called note which is not moving and other parts which is antinote which moving. So, how standing wave work in instrument? First, for string instrument like guitar or violins, when you plug a guitar string, it vibrates and create wave that move back and forth along the string. At the end of the string, where it fits, the waves bounce back and combine with new wave. This form a standing wave. The sound you hear depends on length of the string, which is shorter string make higher pitch sound. And second is tightness, which is tension. Tighter string vibrate faster, producing high pitch. And lastly is tightness. Thicker string make deeper, which is lower pitch sounds. Next, for the wind instrument like flute and trumpet. When you blow air into a flute or trumpet, the air inside vibrate, creating wave in the air column. This wave bounce off the end of the instrument and forms standing wave. The length of the air column, which is how much air is vibrating, decided the pitch. It covering holes in a flute makes the column longer, creating lower note, and uncovering holes make the column shorter, creating higher notes. Last is percussion instrument, which is drum. When you hit a drum, the drum head vibrate. Wave move across the surface, bounce off the edge, and form standing wave pattern. These patterns decide how high or low the drum sounds. Tightening the drum head make it vibrate faster, producing a higher pitch. Okay, now we move to the next part, which is advantage and disadvantage of standing wave in musical instrument. For the advantage, there are three, which is produce specific notes and pitch, which is standing wave allow musician to produce specific notes and pitch by controlling the vibration frequency, like adjusting string length or air columns length. Second is efficient sound production. Instruments are designed to amplify standing wave, making sound production efficient and loud without requiring excessive effort. Last is rich and harmonic sound. Standing wave naturally produce harmonic overtone which enhance the richness and theme of the instrument sounds. For the disadvantage of the standing wave in musical instrument, there are complex design requirements. Instrument must be carefully designed and tuned to create desired standing wave pattern. It requires precision engineering. Second is sensitive to environmental change. Factors like temperature, humidity or wear and tear can alter the material properties like string tension or air density. It will affect the standing wave pattern and the sound quality. Last is limitation in frequency range. Standing wave can only form at specific frequency, which means instruments have limited range of note compared to some electronic device. For the conclusion, standing waves are fundamental to the functioning of musical instruments. It's playing a vital role in producing sound, controlling pitch, and enhance the richness of music. By leverage principle of vibration, reflection, and resonance, instruments like guitar, flute, and drum create unique and harmonic sound that define musical expression. While the application of standing wave provide advantage such as precise pitch control, rich theme, and efficient sound amplification, it also comes with challenge like environmental sensitivity, design complexity, and the need for skillful handling. In enhance the study of standing wave, not only depends our understanding of the physics behind music, but also highlight the ingenious way in which science and art come together to create the diverse and beautiful sound we enjoy.